Hi everyone. So today we're going to carry on with the inverse of matrices and using it to find solutions to linear systems. Okay, so we'll go through another example and then we've got a few properties of the inverse to go through. So like I said last time, when we did the transpose, the trace, and the determinant, those three things also have a couple properties with the determinant. Sorry, not with the determinant, with the inverse. Okay, so they all related like that. Okay, so let's get started with the example. So we have the following system. So 2x plus y plus 2z is equal to minus 2. Minus 2x plus 2y minus z is equal to minus 5, and 4x plus y plus 2z is equal to 0. Okay, so just a note on this, remember that you can only take the inverse of a square matrix. So if you're trying to solve a system like this, then you have to have the same number of variables as equations, to make a square system. But if you're using your row operations, remember you can have 4 variables and 5 equations, or you can have 3 variables and 2 equations. And we discussed that you can have different types of solutions in those cases. So you can have inconsistent systems, dependent, independent systems, and that depends on those numbers. Okay, but if you're using the inverse method, it has to be square, of course. Okay, so the first thing is to take the system of equations and rewrite it into one matrix equation. Okay, so we can write this as 2, 1, 2, minus 2, 2, minus 1, 4, 1, 2. So that's our coefficient matrix. This is going to be multiplied by x, y, z. And then this is going to be equal to minus 2, minus 5, and 0. Okay, so we get one matrix equation from this. And if you do the dot product of the rows with the x, y, z column, you get back to the original system of equations. Okay, so nothing's changed. We've just rewritten it a bit. Okay, so we can call this first matrix A. We can call the second one B. We can call the third one C. So what we've got is A times B is equal to C. And what we really want is B, because that gives us our solutions X, Y, and Z. So what we want is B is equal to A inverse times C. Okay, so we need to find this A inverse. Okay, so let's do that. We write down A is 2, 1, 2, minus 2, 2, minus 1, 4, 1, 2. Just checking we haven't made any sign mistakes. No, that looks fine. Okay, so that is step 1. What we need to do is take the transpose of this matrix. So A transpose is going to be 2, 1, 2. So first row becomes first column, minus 2, 2, minus 1. Second row becomes second column, and 4, 1, 2. The third row becomes the third column. Okay, so you can call that the second step. So now that we've got the transpose, we need to find all of those smaller determinants. Remember, there was those 9 that we put in that grid. And remember how we found that? We block off the first row and the first column, and the little submatrix that's left over, the determinant of that is going to be our first entry. So in our grid, we've got the 2, 1, minus 1, 2. That's the submatrix there. This determinant gives us 5. So that's our first entry. And then we just continue this for the other entries. So we want the second bit. So that is first row crossed out, second column crossed out. The leftover entries are 1, 1, 2, 2. and that just gives us 0. And we can do the same for all the other entries. Okay, remember we need 9 in total because it's 3 times 3. Okay, so let's just go through the other ones quick. So we're going to have 1, 2, 2 minus 1. That's going to give us minus 5. Next row, we're going to get minus 2. There's a minus. Sorry, that got erased there. There's a minus there. Minus 2, 4, minus 1, and 2. That's going to give us 0. Next one's going to be 2, 2, 4, 2, 2. That's going to give us minus 4. The next one's going to be 2, minus 2, 2, minus 1. That's going to be 2. Okay, now we're on the last row. That's going to be minus 2, 4, 2, and 1. That's going to give us minus 10. The middle one for the last row, that's going to be 2, 4, 1, 1. That's going to be minus 2. And finally, the last one, that's going to be 2, minus 2, 1, 2. And that's going to give us 6. Okay, so once we've got our 9 entries, we can then find that adjugate matrix. I've got a question here. How did you get 5? 5. Okay, so for the first entry here, the first row, first column, sorry, that's a 2 there. We block out the first column. We block out the first row. So that's how you get this element. And we look at the submatrix that's formed. This little green matrix here, the 2, 1, minus 1, 2. We take the determinant, and then that gives us 5. Okay, and then you just do the same for all of the entries. So first row, second column, you block out the first row and the second column. You look at the sub entries, you take the determinant, and then that gives you your next value. Okay, does that answer your question? Okay, awesome. Okay, so that's how you get that one. And then you just do the same thing for the other 8 entries. Okay, so now we've got this. We can then form that adjugate matrix. But remember, we need to multiply alternating entries by minus 1. So it's going to be something like plus, minus, plus, minus, plus, minus, plus, minus, plus. Like the checkerboard pattern, and then the alternate ones are minus. So in this case, we're going to get the adjugate matrix of A is going to be 5, but we leave that alone. The next one is 0 times minus 1, that's still 0. Minus 5, we leave that alone. 0 times minus 1, that's still 0. Got the minus 4. 2 times minus 1, so that's minus 2. Minus 10 stays the same. Minus 2 times minus 1, so we get a 2. And 6 stays the same. Okay, so don't forget this step here. Okay, you're going to end up with sign mistakes if you forget to do this alternating multiplication. Okay, final step is to divide this by the determinant of the original matrix. Okay, so if we go back up here to A, we want to find the determinant of A. So that's going to be 2 times, and then the subdeterminant, we cross out the first row, the first column, and that gives us a subdeterminant of 2 minus 1, 1, and 2. Then we've got the minus 1, and then the subdeterminant will be minus 2, 2, minus 1 there, there's a 4 there, and then plus 2, and then in this case, the sub bit is minus 2, 2, 4, and 1. Okay, exactly the same procedure as we used to find these 9 entries. Okay, you're just looking for the sub matrix. Okay, so this is going to give us 2 times 4 plus 1, minus 4 plus 4, so that's a 0, and then plus 2 times minus 2 minus 8. Okay, so 4 plus 1, that's 5, times 2 is going to be 10, minus 20, so that's minus 10. Okay, so we got a determinant of minus 10. So we go back to the bottom here. We're going to take our adjugate matrix and we're going to divide it by minus 10. So a inverse is going to be our adjugate matrix divided by the determinant of that original matrix. So that's going to be minus 1 over 10 times 5, 0, minus 5. 0, minus 4, minus 2, minus 10, 2, and 6. Okay. And to avoid any sign problems later on, let's take this minus 1 and multiply it inside. Okay, just to get rid of some of those negatives. Okay, so this is going to give us 1 over 10 minus 5, 0, 5. 0, 4, 2, 10 minus 2 minus 6. Okay, and then we don't have to worry about that minus on the outside. Okay, so now that we've got the inverse of A, we can multiply this by C, which was this over here. So A inverse times C, that's going to give us our solutions for X, Y, and Z. Okay, so let's do that. So X, Y, and Z as a column matrix is going to be A inverse times that C. So it's going to be 1 over 10 minus 5, 0, 5, 0, 4, 2, 10 minus 2 minus 6. And times by, that was minus 2, minus 5, and 0. Okay, so we've got a 3 by 3 multiplied by 3 by 1. So the answer should be a 3 by 1, which is exactly what we're looking for. Okay, so everything still works out with this matrix multiplication. Okay, let's go and do those dot products now. So we have 1 over 10. We need to take this row from A and multiply it by the column of C. So we're going to get minus 5 times minus 2 plus 0 times minus 5 plus 5 times 0. Okay, so that's the dot product of the first row with the first column there. Now we need to do exactly the same thing for the other rows. So we're going to have 0 times minus 2 plus 4 times minus 5 plus 2 times 0. Okay, that was the second row. And now the third row. 10 times minus 2 plus minus 2 times minus 5 plus minus 6 times 0. Okay, so that's just doing the dot product of the rows with the column. Okay, so in this case, there's only one column, so it's pretty simple to do. Okay, so let's simplify out these sums. So we get 1 over 10 minus 5 times minus 2, so that's going to be 10. The zeros don't do anything. 4 times minus 5, that's going to be minus 20. 10 times minus 2, that's minus 20, plus 10, so that's going to be minus 10. Okay, so we just simplified those sums there. And then finally, this 1 over 10, we can multiply inside. So we get x, y, z is equal to 1 over 10 times 10, that's 1. 1 over 10 times minus 20, that's minus 2. And 1 over 10 times minus 10, that's minus 1. Okay, now you can leave your answer like this as a column matrix, or you could just read off the entries. So we know x, that's the first one, Y, that's the second one, and Z, that's the third one. So you could just say X equals 1, Y equals -2, and Z equals -1. -1. Okay, but either way is fine. You can leave it as a column matrix, or you can write out your solutions X, Y, Z. I'm happy with either way. Okay, are there any questions about this example? Okay, so let's just go over those steps one more time so we can just number them. So the first thing that we need to do is write it as a matrix equation. So once you have your matrix equation, then you can identify your A, B, and C. Okay. Number 2, we want to find the transpose of your coefficient matrix, like that. Then, number 3, you want to find these 9 entries. Okay, this is called the cofactor matrix, but you don't need to worry about the name. Remember, these are just all the subdeterminants. Okay, so that's number 3. Okay, and number 4, we use those subdeterminants to find the adjugate matrix. And remember to multiply your alternating entries by -1. Okay, using that checkerboard pattern there. Okay, and finally, number 5, you're going to take your adjugate matrix, divide it by the determinant, and that gives you your inverse. Okay, so those are the steps to find the inverse. If you want to then find the solution to the system, you would then multiply it by that C matrix. So that would be your step 6. Okay, and then that gives you your X, Y, and Z. Okay, any questions before we move on?
No questions from me.
Okay, I've got a question in the chat. So when you divided 1 by 10, while the determinant is -1/10. Sorry, there's a, yeah, so there's the minus here. So it's -1/10, and then I multiplied the minus inside, so we didn't have to worry about it later on. So let's just make a little note. No, sorry. Multiplied by -1. Okay. Okay, sure. Yeah, so I always try to get rid of the minus signs to avoid any sign mistakes later on. But you can do whatever you want there. Okay, if there's no other questions, let's go on to the properties. Okay, properties of the inverse. Okay, so there's 3 important properties that you need to know. Okay, so number 1, if we have a product of invertible matrices, A and B, then AB inverse. Okay, so the inverse of the product is equal to B inverse times A inverse. Okay, so A and B must be invertible in this case. Okay, so you see that the order swapped and then each one gets an inverse. Okay, that's the important property number 1. Number 2, the determinant of A inverse is equal to 1 over the determinant of A. Okay, so remember that 1 over determinant that we had in the front here, this bit, that bit there, the 1 over determinant of A, that is the determinant of A inverse. Okay, 1 over the determinant of A. Okay, and So that's the relation with the determinant. There's also a relation with the transpose. So if you have a transpose inverse, so if you first do the transposition and then you find the inverse, that's the same thing as finding the inverse first and then doing the transpose. So you can swap the order of transposition and inverting. Okay, so these are the three properties that you need to know. Okay, any questions on these properties? Okay, let's have a look at some of the homework relating to these properties. Okay, so you should have done a few proofs in Math 195. So we're going to have a couple of proofs for homework. So number one, prove that if A is invertible. Okay, so we know what that means, that determinant is non-zero. So if A is invertible, then A inverse is unique. Okay, so there's only one inverse. Okay, I'll give you a little hint for that one. Let's just go through number two first. So number two, prove that if A and B are invertible, then a B inverse. So if A and B are invertible, then their product is also invertible, and it's given by B inverse A inverse. So you can prove that. And finally, number three, star. So this is just a bonus. So provide an example of the fact that if A is invertible and B is invertible, then A plus B may not be invertible. Okay, so we know that if we take the product of A and B, if A is invertible and B is invertible, then the product is invertible. However, that is not true for the sum. So if A is invertible and B is invertible, A plus B may not be invertible. So sometimes it will be, sometimes it won't be. So you can either do a proof on that, or you can provide an example. Okay, so that will be for a few more bonus marks than usual. Okay, if you can provide that. Okay, and I said I was going to give you a hint for number one. So hint. Assume B and C are both inverses of A. Okay, so assume that there are two inverses, then show B equals C. Okay, so that's your hint, and this is the typical hint for proving uniqueness of things. Okay, so if you want to prove something is unique, you assume that there are two or more of them. So in this case, B and C are different in inverses. Then if we show that B equals C, well, that means there's only one. Okay, so that's your hint for number one. You don't get a hint for number two, And number 3, that's something extra if you want to try. Okay, any questions about this homework? Okay, so this is the last lecture for the material for test 1. Okay, so test 1 is only on systems of equations, this matrix stuff, and finding inverses to solve systems and so on. So systems in general. And then next week we will start on the new section on vectors and vector spaces. Okay, so any issues with that? So any questions before we go on to the next stuff? Okay, so then we'll start the new section on Monday. Okay, if you have any questions, please let me know. You can also email the tutors, or you can ask your questions on the WhatsApp group. So both tutors are there as well to help, or you can email me as well. Okay, I'll see you Monday. Okay, bye everyone.